Okay. So my work was in the field of computer poetry, which is simply defined as writing poetry with computers. This can run the gamut, all manner of incorporation of computers and software. I've listed here some existing projects that produce poetry with computers, and they all suffer from one of two extremes. The ones I've highlighted here suffer from being too human, because we're trying to write poetry with computers. We want to show that computers can be a very important part of writing poetry, but systems like Racter and Otto Beatnik are essentially Mad Libs. A human programmer will prepare grammatical templates with blanks in them, and the blanks are labeled intransitive verb, noun, pronoun, and all the computer does is pick a bunch of random numbers and then populate those blanks with words, and that's boring, because you can sit with some dice, and you can do that. Similarly, programs, these bottom two, Sparrow and Wasp, rely on human agents to read the output of the program and then say, this is a good poem, this is a bad poem, and that fuels how it produces poems later. And without that human input, the program would just be lost. It would have no direction. It wouldn't know what it's trying to produce. Similarly, McGonagall, though being very complex, McGonagall relies on a set of data structures called lexicalized tree adjoining grammars, or left tree adjoining grammars, rather, L tags, that describe semantics, that describe grammatical entities. And those are combined to grow poetry. Sounds really neat, but humans still have to supply the L tags, and all the output is determined exactly by what humans put into it. So my complaint, my gripe with these existing projects is that there's too much of the human poet left. Humans have been writing poetry for thousands of years, and we're good at it, and we know that. We don't need to prove that again. Some of these other projects, though, are too computer. They take away from the human meaning and the power and the weight of poetry that should be in poetry. The Travesty Engine, for example, takes an input text and some number of characters, so a paragraph and then, say, 5 characters. And it will reassemble the paragraph such that all the substrings, so 5 characters long, will be shuffled in the end result. It can produce neat results, but the program gives no attention to anything like sentence boundaries, word boundaries. It's purely character-based, and you end up with gibberish most of the time. The VSM blog haiku system is more interesting. It takes blog content and then writes a haiku using what content it found in the blog. But what ends up happening is that the data goes through so many transformations in between blog and eventual haiku that you can almost discern no relation back to the original human content. You just end up with a haiku that sounds pretty, but doesn't really tell you anything. It doesn't really carry any weight or any meaning. So what I wanted to get at with my work was human-mediated computer poetry. I wanted to write poetry that couldn't be done without a computer. I wanted the computer to be an indispensable part of the process. But I wanted it to be human-mediated. I wanted to use human media to produce the poetry. So the realization I had one day was that in the 80s, when Racter was doing his stuff, and back in the 60s when Otto Beatnik was doing his stuff, humans had to write a whole bunch of stuff to generate poems from, because you couldn't just go online and go to Google and get millions of lines of text for you to play with and make poetry out of. So what I realized, and what my hypothesis came to be, was that given a large enough corpus, given a large enough this list of pure text, this lines, you can generate poetry that is diverse and meaningful and carries the weight of the meaning embedded in the original human content, but that's stripped of its original intention. It's reappropriated, like when a DJ reappropriates snippets of songs to make a new piece. So, starting with this notion of a large corpus, I decided to implement a William Burroughs cut-up technique. William Burroughs populated cut-up as part of the beat movement. It was something that came about in the Surrealist movement, where authors would just slice up pre-existing works, newspaper articles, novels, scripture, or whatever, and repaste it. I mean, this is very physical. They would repaste these cut lines into new pieces. The book Naked Lunch, large swaths of it were produced. I mean, Burroughs would write, he would type tons of pages for this book, a huge manuscript, and then just chop it to bits and rearrange it, and what you get new sections of the book. Burroughs did this almost as a form of divination. He felt that when you sliced up existing works, you could divulge meaning that was hidden, subtext that you wouldn't be able to find by reading the text linearly. So when you're cutting up, you're finding new meaning, you're inserting new meaning. He thought you could predict the future too. So my eventual goal to kind of crystallize it became to take human content, just like Burroughs, in huge quantities. I'm talking millions of lines. add it with computer automation. I want to take this cut-up process and I want to write an algorithm to do it. And I want to subtract human intent. I don't want programmer contrivance to end up in the final product. I don't want to have the problem that Racker and Autobeatnik suffer from, or even Aspera and Wasp. I don't want the programmer, I don't want me to have too much sway over the output, because I could just sit and write my own poetry. I mean, I know how to do that. It's not exciting in the field of computer science. My eventual goal is to create novel, creative works carrying the weight of human emotion with minimal human contrivance. As you'll see, the user still has sway over the final output of my algorithm. And it has to be made possible by computers, because that's where we're going to find new exciting things when we bring computers into this process. So to accomplish this, there are two major components to my work. Corpora, which are just raw piles of text. I started with 600 lines taken from short stories by Jorge Luis Borges. I found them all online. Used that to test with, and then when I got serious, I wrote a tool that would scrape Project Gutenberg. Project Gutenberg is an online collection of ebooks. They're all free. They're all public domain books. And what's wonderful about Project Gutenberg is they encode all these books in plain text, just pure raw text. None of this PDF doc garbage. So I can scrape it, and it's great. So what I did was I stole, I didn't steal it, it's public domain, but I kind of put on my hard drive with a program 3,727 books. Of those books, I took 1 million lines and decided to use that as my corpus. The other major component is the rule system that I've come up with. So you don't end up with just gibberish when the algorithm's done. You can direct it. You can direct the cut-up technique such that you can say, well, I want a haiku. I want a number of syllables per line. I want 575. I want a rhyme scheme. I want to say what kind of rhyme sound I want at the end of each line. I want the poem to be about something, more or less. I want to be able to say, give me a poem where every line contains a keyword, or where every line is at least near another line that contains a keyword, so fuzzy and exact. And just finally, length. How many lines do you want in your output poem? The algorithm is very short. A lot of the more intricate work are done in modules that I also wrote. Namely, the corpus processing and rules processing are done in other modules. But to simplify the process, this is what I drafted first to code from. We're just going to step through it slowly. It's not that bad. Starting with the corpus, so a whole bunch of lines. We're going to begin by normalizing lines. We're going to take this raw text and we're going to turn it into a list of sentences. So we're going to be paying attention to sentence boundaries, periods, and we're going to be now we just want a list of sentences. Then we're going to profile them. We're going to, for each sentence, see how many syllables are in that sentence, what's the end rhyme sound, what's the text of the sentence. Then we put it in a database, and we can then query. Next, we take input from the user. The user will say, I want an AB rhyme scheme, and I want it to be 10 lines long, and I want about 10 syllables per line. That gets parsed into a data structure that then directs the rest of the process. And we're going to see an example of that data structure right after we finish going through this. Initialize a poem. All a poem is a list of lines, or a list of sentences, rather. There's nothing more extravagant to it than that. So we'll start out with an empty list, and we're going to append to it as we go. So the data structure that we've created from the user input is a list of what I'm calling rule sets. A rule set consists of a couple different rules, like a particular end rhyme sound or a particular number of syllables. We're going to go through each rule set, because we've got one for each line, is what the parsing turns out. We're going to convert the rule set into a database query. We're going to see, okay, well, are there any sentences in the database that have this rhyme sound and this number of syllables that I want? If I find it, we drop down to this, ignore the if block, and we drop down to picking a random one. For at this point in my implementation, all the candidate sentences selected from the database, we just grab a random one and append it to the poem. Great, move on to the next line. But if we don't find one, there's a problem. And if I didn't address it, this wouldn't be an algorithm, because we would just spin our wheels infinitely looking for sentences that don't exist. So what this code does is drop into a weakening phase. To weaken a rule set means to liberalize one of the rules in it. So say we're looking for a rhyme sound and we're looking for a number of syllables. Well, I wanted 10 syllables, but now I'll take anything with 9 syllables to 11 syllables, or just some range of syllables. And we'll keep liberalizing them until either we find a list of sentences, so if S, then great, typo, it should be S prime. We'll leave the weakening phase and we'll move on. Otherwise, we'll keep weakening. And eventually, rules will just decay into the trivial rule. The trivial rule is defined as the rule for which any sentence satisfies it. Finally, when we're done, just put down our poem. So we're going to step through an actual generation from start